Right, hey guys, sorry for the delays, and I'm about an hour late into this. I've been setting like a bunch of things up for streaming content. I'm basically trying to just like build an app. I learned uh, a lot of stuff about Angular 6 and Node.js recently. I got caught back up. And so I want to be able to build an app and just demonstrate like my skill and just kind of build something cool. I've got a lot of really good ideas for like graphics programming. Whoa. But I can't ever really get like an environment that kind of like set up. But, I don't know. I can't really get an environment set up to allow me to to rapidly build uh, particle shaders basically with very specific rendering pipelines and like I don't really care so much about like scene graph stuff, but I want to do some like pretty advanced stuff with the scene graph and basically use or not the scene graph the rendering pipeline. Um, so whenever you're doing graphics programming with WebGL, you have to encode all these. Well, you have to build a bunch of objects, register a bunch of objects, via the JavaScript interface to the underlying graphics like bindings, which map down to the like I guess graphics card drivers. So you go from like Angular land or like browser land to like the WebGL like bindings to OpenGL. Then you go from OpenGL down to the graphics card, and so you build you register a bunch of objects like programs, and every program has a vertex shader and a fragment shader. So your vertices are your vertices are your points. Your fragments are the surfaces of polygons, or I guess a line is not a polygon. You can draw points and lines, and you can draw simple polygons, usually triangles, triangle strips, or quadrilaterals. And anyways, so I don't just want to draw like objects. I don't just want to build like 3D objects. I don't want to take code that somebody else has built because I want to I'm really interested in the lower level stuff. When I worked with graphics in Swift, um, I used a library called Metal, and I really liked it. The complement to Metal for most platforms is something called Vulkan, and it basically it kind of like unifies OpenCL and OpenGL. OpenCL is like the computation. It's a it's, it's a complement to OpenGL, but instead of being intended to be used for graphics, it's used for just like generic compute. Well, Metal and Vulkan are like decoupled from any notion like of design that's like tightly coupled to the intended use, like tightly coupled to graphics or tightly coupled to compute. Instead, it kind of like destructures everything and just lets you do basically whatever you want with the hardware. And then recently, a lot of chip manufacturers have been and uh, consumer I guess computing manufacturers and you they've been putting like this stuff called shared memory or this feature called shared memory. They've been designing a feature or they've been designing shared memory for like the graphics card and the CPU or the GPU and the CPU, so that the CPU and the GPU can both access the same sets of memory under certain conditions. So so they can also like write to the same sets of memory under certain conditions. And this is important because there's something like if you really have done like high ceremony advanced graphics programming, there's something that you'll recognize called like a a technique called blitting. So you'll have to encode like blitting commands, and what that does is it like pipes in data from memory to the graphics card, or pipes data from the graphics card to memory. So you like read and write and push large amounts of data like around as fast as you can, like copy only and read only data. Like as fast as the GPU can access it, you push it out of there and like push it to the next location. So you may have like a chain of render pipelines, and you like run the draw calls for the first one, and then that gives you a result. But if you don't want to use blitting, you have to pull it out of the GPU or the CPU, and then put it into the next location. Or like, there's a lot of complexity there, but that's the easy way to do it. Instead of use the blit encoder, you take the data that's already on the GPU and just blit it to another, like blit it to be registered to like register as input for the next set of draw calls. And that way you don't have to move around massive like sets of massive like memory sets like in and out of the GPU. And like one of the things that bounds I/O on computer hardware is the actual time that it takes to shuffle data through the bus. So if the data doesn't touch the bus, like in the backbone of the I guess, which is the backbone of the motherboard, it basically connects all the hardware together, and it's exactly like an Ethernet bus. So when Ethernet was first designed, like you basically just plugged in the network, everybody got the same messages. Like as everyone else, and like if you added too many people to a network, you would get a lot of collisions because everyone's like this, and you'll see this like weird like kind of like design element of like like flowcharts and design documents that deal with like technology, and it's just like a long like backplane or a long rectangle, and everything's connected directly to it with like vertical lines pretty much. And that's the bus, because very literally like it's just like something that everything is like connected to, so that it like so there's almost equidistant, but apparently accessing the bus is a significant factor. If you want to run like tons of like compute calls or compute draw calls, I guess, and if you have to extract data from the GPU, move it to the CPU accessible memory, like, and then move it back to the GPU like memory, like you have to use the bus to do that. But if the CPU and the GPU are like tightly connected, then it means that they can shuffle data around, or some like you can configure like modes of memory access that allow you to like. Am I even on here? Sorry, I'm still getting like. I wanted to start streaming at like 9, and then just ran into OBS problem after OBS problem. That's a streaming software that I use, but so I'm trying to figure that while trying to like tell some stories. And also like I ran into some resolution issues where like I had configured a bunch of things, and then I thought that I was streaming at 1080p, but I'm not. So then it messed up my scene thing. So let me see which window I'm on. Alright, so, and by the way, this is my Trello that you're seeing. I'm going to expand it so like it appears to be larger. I'll just go ahead and do this over here so it's... Anyway, so that like the I/O like concerns for moving data around to be sent into like the GPU like to be used for like I guess draw calls or whatever. That's a pretty significant bottleneck, and that's why that's like the thing that like required for like a new like design, or enabled a new design for like things like Metal and Vulkan. Like without that, there's some things you can improve with graphics hardware, but not like not to really like not that none that could like justify like a complete like redesign of like like widely used libraries like OpenGL and you know, stuff like that. So like with the shared memory stuff, it opens up all these possibilities, and then like all of a sudden like you have the ability to like you've got the ability to, you know, move the like data around a lot faster, or just write to the same regions, and then that opens up like that just completely revolutionizes the way that you write software for graphics. So I'm like really interested in learning about graphics, and also I want to work on something to show people kind of like what I can do, and I didn't mean to get lost in that like incredibly like my somewhat technical like discussion about graphics and view. See, I'm trying to. Oh god, I gotta re-add sources to the thing. That's great. Anyway, so I'm really passionate about graphics. I like thinking about stuff at the low level. I want to like work on like learning math. So I got this book. Let me go grab it. I'm gonna get distracted. So I've got this book. The exterior analysis, and let's see if I have any existing sources. No. Exterior analysis is about like exploring the same kind of math that's used for Stokes theorem, basically, in like a 15-word summary. Like there's like so vector calculus is a generalization of the derivative to higher dimensions into vector fields. So it allows you to do things, and then you get up to the Laplacian, or you build up to the Laplacian, I guess. And there's a lot of other things in, you know, vector calculus that like I glossed over like by reading Wikipedia. But and then you have these things called you have these these are not operators. You have curl and divergence, like two functions in vector calculus that like behave in kind of complicated ways for higher dimensions and for like different like kinds of spaces. And so you can actually generalize those. You can generalize divergence and curl and define them in like, because they're kind of complicated to explain, especially in like, you know, more than 3 dimensions, or like in like more complicated systems of equations like bilinear, multilinear, or, you know, other kinds of systems. But when you like define them in terms of like the wedge product, and I'm not really sure about, like, I don't know this stuff very well, which is why I got the book. God. What do you mean I can't just have the whole window? What's going on, please? Anyway, you generalize like divergence and curl in terms of like very simple, like very simply stated, very simple looking like expressions based on like the wedge product and the other thing. But Stokes theorem is about like dealing with like fluid flows and math in fluid flows, and you know, like make certain assumptions about like how the system is behaving. And these are the kinds of things that like if I sit here and try to like explain it to you or to anyone, like if you haven't come out of like an engineering school, you're probably like gonna like gloss over, you know, like it's just not really it's gonna be hard to understand, especially if you just have somebody talking about it. It doesn't make any sense. You're like, okay, so you can generalize the thing that I've never heard of. Okay, all right. So, but I found these. God, why would I want a window? So probably just figure this out real quick. I think this is it. Is that right? This is like so complicated. Why is it only covering half the screen? This makes no sense. Oh, I think I know why. Never mind. But anyway, like once you open that door to exterior calculus and you combine it with like multilinear like bilinear multilinear equations and like algebras, and you there's something called like cochain like cochain complexes, or like, and that's from like the branch of math that studies like cohomology groups, I guess. I think it's just homology. I see a lot of the IAS videos on this stuff. Like, or I used to about like a year and a half ago. All they talk about is L functions. I have no idea what it is. Try to like can't even make it past like 3 minutes of videos. Anyways, so you have it basically defines like it's amazing. I'm only like 9 pages in this book. I've glossed, I've like flipped through it. Point is, like, there's some amazing stuff, and once you apply the ideas from exterior algebra, exterior calculus, exterior analysis to once you apply the ideas of exterior algebra and calculus to exterior to linear, bilinear, and multilinear systems, you end up with like this structure that allows you to like completely like explore all of the possible ways. You get like a basically like I think it's a countable algebra, but it's like an algebra that I think this is where I'm kind of like just like kind of made this insight, but you get like an algebra that gives you every possible like valuation of a derivative, and like it's really, and I'm not sure if I can. I'm not very precise, so I'm just gonna give up. But it's really cool because it turns like a linear system into like, I'm not sure if it would turn a bilinear system into like a very compound version of itself. But then you still like, if like in certain situations and in certain systems, you can like make guarantees about like just like being able to like know things and be able to like predict things, and being able to like, especially in linear systems, I guess, like go from like one point of the space to the other point of the space, and then like uniting like every possible space and every possible like system of equations that could be that meets a certain set of conditions like within that space. So you unite everything within like the dual space of the system. You can go from the space to the dual space, the dual space to the space, and then like it's like, and I'm only like 9 or 10 pages into this, but like I understand how it can be used, and it's just like I don't know. I never took multivariable calculus, so I kind of like went from there to like vector calculus, but that's pretty much the same thing. And why is it not? It's like just really not letting me do anything on this. Like, I'm sorry. Like, I don't know if anyone's watching. It's really not what I wanted. I mean, I guess I could stretch everything out. I don't know why it's like, why my videos. Oh, because it's giving me the window. Okay, I'm just gonna shut up. I'm gonna fix this real quick. I'm sorry. We'll start building something soon. Loopback is let me explain a little bit more about Loopback. Loopback is a pretty amazing tool. It's kind of tough to work with at first, but then I found this project that was written in Loopback, and it's like it's an Internet of Things like app, and like it was just like a pretty complete example app with a very complicated like domain structure. So I can probably like I don't know. It's just a pretty amazing thing to like see how they like register all the Internet of Things devices, and have like this notion of like applications that are distributed across like Internet of Things devices, and it's just like I don't know, it was very interesting, and then it ended up being like the best example of a like loopback application. Um, and like there's a lot of like content out there. Like Loopback is a Node.js like web application framework that is like an API like first like framework. So like I think you can serve some static content from it, but like you just like it doesn't like Rails, like Ruby on Rails and Sales.js and most of your like larger like frameworks, not the microservice frameworks, but the larger frameworks have are they're built around like the idea of like model view controller or I mean they're built on model view controller or some variation of model view controller, sometimes with like a view model. Um, but loopback is like controllers why, and it just like wraps all your data with like routes, and then you get Open API like you get like a Swagger.js Explorer basically with like that's been like overlaid with loopback logos and stuff, and um, it like you can make web requests with it. Like you don't even need Postman to make web requests against your API. Um, and so you can just like really hit the ground running. It tells you your routes, like it's self documenting. It like it's really good. Some things are kind of frustrating because like it imposes like some things like onto the like it imposes its like notions onto the like design of your app. So there's some things that you can't do, and but like once you kind of get around that, like once you just kind of like because it seems complicated at first, but then if you understand like oh no, if you like shard things this way, then like you can just like guarantee that like you know you like that's not gonna be a problem. So like, there's some things that like there's some gotchas that I ran into when I was kind of like first getting started with it and learning it. But it seems to be like 4 or 5 times faster than from like a. Uh, it seems to be like much faster to work in, much faster to like produce features because if you're working in like the if you have two projects, if you have a front end framework and a back end API, like that can be tough to like manage like both of those at the same time, like while uh, while like basically like managing the deployments, managing DevOps and stuff, and managing like build scripts, um, and trying to like get integration tests to work everywhere, um, so that like it's so that if so that you can be like agile, like if anything like were like to happen, if you were like wearing all these hats like DevOps, like back end, and front end, and like then if like something happens, and if it's a multi-deployment app and if something happens, you need to be able to react quickly, and so you need a lot of automation in place, a lot of like anticipation of problems, automated detection of problems, which is what like integration tests are kind of about. And without that kind of stuff in there, like it takes kind of a lot of time to put together. Um, it's just uh, me personally, there's some problems that I know that I'm going to run into. Um, just with like the process, like it's really like it's not so hard with the like if you're on like a I don't know, it's not so hard like if you're working with like a lot of other people on the same software project. Because some of the, like the response, like some of the different responsibilities can be like more effectively like distributed everywhere. Why? But why? Yes, I am sure. Sorry. All right, that's what I'm talking about. It's a little bit off, a little bit too large. To maintain the same aspect ratio. I think it really like use the new UI here. There's a new app that lets you stream, or there's a new stream streaming app. Like it's a version of OBS, but it's like slightly reworked. I guess. But the user interface looks pretty cool. Whoa. I'm always like very picky about like knowing that like knowing that something is precisely proportional. Like I mean, I need that video to be like exactly 1/2 and not a pixel over. Whoops. I didn't expect so many issues. I would have been a lot like would have been streaming a lot earlier, but then like OBS is like kind of a pain to configure properly. I've been like streaming on Facebook, and the video quality is just like it's like whoa. And then I just found out that it's like rescaling my video, and I don't like that. I like to like let me tell you what the ones and zeros are, and like that's what they are. Don't change them. Like don't re-encode the video. Every time you re-encode the video, you're like layering in like a little bit of noise, and then unless you can guarantee that it I guess is lossless, but like anyway, so I can't believe I didn't realize that. It takes a lot of work, but then once you get it set up, like you can usually return the same set of settings. Those kind of tend to distract me sometimes. I believe that's just right about like I don't know. Alright. So I think we're good to go on this monitor. Like I don't know what the problem is. Idiomorphic epistemology. Let me tell you about that. Sorry, this isn't one of those videos. Oh my gosh. It fits. It's horrible. It's completely messed my layout out. Like, up. What am I going to do? Alright, so I'm really excited about doing this because let me tell you a little bit more about this this project idea that I've got. So I want to build something that lets me make like animations, lets me make simulations, especially like particle simulations. I'm interested in like the lower level aspects of the graphics pipeline, but I don't actually want to spend my time like mucking around in those lower levels. It's like you really get bogged down with code, but the nice thing about like computers is that like they normally the nice thing about programming is that normally like you can like create your own language within the programming language, whatever you create, like a domain specific language or something, and you know, like there's something like XML and web components and stuff, and you can really like just declaratively structure what you want, declaratively structure the logic, and code the logic of like you know the structure of objects that you're working with, like just in the like hierarchy of HTML nodes. And so so this is exciting. That's basically what I was doing, or what I wanted to do in the Spectra library for Swift. So I was really interested in in these lower level like aspects, like custom pipelines. So like there's something out there called 3JS, and I'll get back to the web component stuff in just a second. There's a library out there for graphics in the browser using WebGL called 3JS. It does let you work with WebGL 2, I think, but it does a lot of stuff for you automatically, and it's really like programmed around WebGL 1, because WebGL 2 doesn't like support the browsers very well. Oh, this was supposed to be my like monitor that like had a space on it where there was the like windows weren't visible. Just great, because like it's one thing I spent like a lot of time setting up. Like I need the screen space like where it doesn't broadcast. This is not happening. Oops. Anyway, so 3JS does so much stuff for you, but it does almost everything that it does in WebGL 1. So it doesn't like, so if you use a lot of its objects, like they're not going to be using. Let me like pull out the API real quick. Just kidding. There it is. You know it would be better if I shared. Yep. Oops. Tiling window managers. You either love them or you hate them. I love them. They're fantastic. Although I found it's kind of a mistake to assume that like allowing all the windows to cover all the space on the screen is kind of a like I don't know. It seems to distract, like it seems to like hide information from me. Oh, you are certainly like guaranteed to be able to like get that like 100% efficiency out of your like real estate, like ostensibly. Like you like. Some things it works really well, some other things it doesn't. What am I looking for? Oh, trying to figure out where I'm going to put stuff that I don't want people to see. Go, tiling window manager, go! Just need to line up this video. See, I've made a mathematic assumption about a very peculiar lattice. See, it's a lattice. But I don't recognize it's a lattice quite yet. What about now? Lattice. Just kidding. That's kind of mostly irrelevant, but lattices are really cool. But the point is, like, you can make certain assumptions and avoid having to like informally calculate anything. Just if you understand like certain like rules of the system, and then like understand that if you don't like, you find like the lines outside of which like. As long as you don't color outside those lines and you stick to like some opinionated not overly rigid like set of rules for doing something, then you like avoid like so many problems like implicitly, or you avoid creating the possibility for uncertainty. So. Alright, let me get to the WebGL 2 documentation. So I'm going to this is basically going to be an overview video. I'm going to try to get to, whenever I generate the Loopback app, I want to do that at the beginning of the video. So I might take a little break later on, but I just kind of want to like go over what I plan to build. This is going to be a series of videos, by the way. It's probably going to take me like I don't know, like I don't want to do it 100% on streaming, but then again, like if I'm streaming, like building the app, then I want to make sure that there's like at least some elements of continuity. There's some things that I don't want, like I'm going to be signing up for like setting up like some stuff in like the Google Cloud, so or using Google Cloud. So I need storage for audio samples and overview of the project. So I want to be able to work with math. I'm interested in math. I'm very intuitive with certain things, but trying to explain that to other people is really hard to relate to. But like I also like I think I would be like a good artist. And let me like grab it real quick. Never mind. That's stupid. All right, so let me show you my unfinished art. Maybe I'll finish it someday. That's great. WebGL reference. Anyway, so I can express myself artistically if I can simply like visualize some of the things that I'm thinking about. And I'm actually pretty good with like visualizing it internally in my mind. And I kind of want to be able to like, this may not have enough memory to run or something. I just want to be able to demonstrate like to other people the things that I see, and then also like be a little bit more rigorous with what I'm trying to learn. Like I'm very passionate about like physics and economic physics. This is economic physics. I've discovered like social physics, and I'm learning a lot of stuff like is like I don't know. It needs to be a lot more in depth. It needs to be a lot more precise, and then I need to be able to like I can't convey like my ideas in like words. It's just easier if somebody has like a moving picture, which is what this is supposed to be. What is going on here? Oh great, it's broken. Oh, here we go. I'm going to will this window over to the, oh, there it is. Like, I mean, it's pretty powerful. Like, you can just, like, flick around through the windows, move windows around, cycle the windows. Let's see. There we go. I can change to a column layout, move things around. I don't really have to think about it. I'm just like, oh, I want this here, here, here. I want it to like, yeah, like, and so I can switch back to the other layout. There's other ones too. There's other. This was Amethyst. I can move windows between monitors. I can like. This is desktop 7. This is desktop. That was desktop 7. This is desktop 8. Yeah, this is desktop 8. And then so I can open up OBS. I used to have a lot of like global hotkeys wired. Very passionate about the keyboard. So anyway, I want to be able to demonstrate. I want to be able to illustrate mathematical ideas with like trippy and interesting like animations that also like maybe have some kind of like important like mathematical ideas. So I just want like particles on the screen, a particle shader, and I'm doing things that are very difficult sometimes. So one of the things, if you actually want it to run in real time, like and in the browser, you can get it to like typically you can get things to run a little bit like faster in the like on the like with like C or C++ and like CUDA or OpenGL without like where you compile the program with the you could also use Java to get most of those speed benefits, the performance benefits, but you're not actually going to get that much. You're only going to improve it when you are not GPU bound, and you're actually going to become GPU bound pretty quickly. And the only time you're not going to be GPU bound is when you're drawing lots and lots and lots of things, like when you have like pretty irregular like sets of draw calls to encode. Because you have to like, there's like a point, like it's ridiculous. There's a lot of like very interesting optimization problems with graphics. There's a like it's just use a graphics engine. Don't do what I'm doing. It's stupid. I don't want to build my own graphics engine, but I basically want to build like some lightweight framework so that I can just like and then like like, so there, yeah. What am I doing over here? I get like distracted about what I'm talking about. I like talking about it. Like this is why like I'm so irritated all the time, or I appear kind of irritated all the time because it's just like I don't know. I want to be good at this stuff, and I know what it takes to like dedicate yourself to something, and I just feel unable to dedicate myself to like consistently retooling my like skill set as fast as I could. I like I like and I've I don't know. I don't want to really complain about that because like it's just that like I'm in a small area and I haven't really driven for a long time and kind of been like a hermit for kind of a long time. Where is it going with this? Oh, Trello. Let me pull up Trello. Actually, I gotta send this over to the other monitor. I'm just like showing up like there we go. Okay, showing up. I really wish I had that space on my screen where like I could hide things. Just, like that's what I'm saying. If you have a set of rules like that, and you just like don't like you're like oh I'm not gonna do that. I'm not gonna color outside those lines. Then like you'd be like oh like well I don't have to like assert or like I don't have to assert the state of the system. I can just know that like if you don't like if the system like always like adheres to these constraints like then it'll never end up in a state that like makes something else happen. And then if the only other way to do it is to just do random things, then you always have to like be like I'm gonna look over there, and looking is really inefficient. I'm gonna like look, and you can look in a literal sense, like oh where did I put my wallet? Like I don't know, I wasn't paying attention. Or you can look in like a figurative like sense, like you can direct your focus, like your mental focus or your intellectual capacity towards some idea. But you have to validate its state. So your mind is like, let me run a little program, like, blip, 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 blip. Okay, now I'm back. And then, oh shit, like, I'm not aware of whether or not, like, certain, like, spatial, state assumptions, I'm not aware of whether, like, certain assumptions about state have, like, been violated. Because I don't enforce any kind of, like, rules. It's very, like, functional programming. These are the ideas of, like, functional programming. Like, don't have, like, mutability. Like, just never allow mutability and just always create new objects. And then immediately, like, eliminate the objects and structures that you don't need. And then you never encounter certain problems. Well, like, if I don't have to, like, check something and I always know that the information is going to come to me or that the information is implicit, then I don't have to think about it. It's fantastic. I don't know. I really need. Yeah, I'm gonna have to like. I'm gonna probably keep going till I'm gonna explain the gist of what I'm doing here. I've got a bunch of features laid out in Trello, and I'm trying to like make this set of videos a lot different than the other set of videos that I've been producing. So in those videos, I'm trying to talk about my writing. I'm trying to just like kind of like talk about things. It's not really working for me to be able to like facilitate my writing, and it's like it's hard to that's what the writing is for. It's very easy. Like I don't have to explain something to someone. I can just like write it, and like if that's a new article on the blog, then like people can read it. If they don't want to read it, they don't have to. Blah blah blah. But so if I talk about it, it's just like very rambling, and so this series is not going to be rambling. So I'm gonna. First episode, I guess, is, but all right. So I'm going to be building an app that lets you build audio samplers, or like a drum kit, like a sampling like thing with WebAudio. So I'm going to use WebAudio to make it so that you can like create sets of samples that are like bound to certain like buttons like in a widget on the screen, and so you'll create it in that kind of interface, which I mean I don't know if there's a simpler way to do it really, But then you'll be able to play the samples with the keyboard, like using Web MIDI, and that's all very simple. And when you just have one, like when you're just building one sampler, it's like, it's pretty simple. Like, I'll, I'm I just need to take my time here. I'm going way too deep into tangents when I need to be focused on an outline. So I'm going to be building a sampler widget with WebAudio. It lets you play like any kind of audio sample, like short audio samples, like hi-hats, kicks, drums, like anything you would put on a drum loop, and it'll be able to play MIDI sequences basically, and from there, I want to create a visualizer, visualize the audio, but the idea is to make the like visualization piece like extensible. So there's a site called Shader Toy. And this isn't a project that's going to be a business or anything. It's just like something I'm doing because I want like a good place to like showcase like my work, or showcase like things that I work on in a visual way. It doesn't require long like 400,000 word like blogs, and like because I just want to like build something that's cool, that's interesting, that helps me like use my mind, and that helps me progress in math while like being able to demonstrate to people that like I understand the math at a lower level because I have applied it, and it'll help me get to that point where I feel like I'm more confident in the lower level aspects, because there's an expression like he knows the music, but he doesn't know the notes, or he knows the songs, he knows the music, but he doesn't know the notes. So it's like, and those notes are actually kind of critical. That's where like, because I mean, you can understand. It's easy to understand how something is used, or what it's used for, and how things can be combined together, or where they overlap. But then, if you actually want to like, I don't know. I've been so fascinated by like data science and computing, and like doing cool like intense things that like make your computer hot. Uh, I've been thinking about this nonstop, and I cannot find anyone that like I don't know. I just can't. And I know, and like other people don't get it. Like I know what it's like to be able to easily find like so many people like that. Like and that's my problem. Like I have like there's like friction in my life that like it's like it makes it like it makes it so there's lots of things, lots of dependencies that I need to like take care of first before like other things can happen, like me like meeting people. So I like I can drive now. That helps a lot. Yeah, I have money now, so that helps a lot, and I can like I can go do things like go like to the like I don't know. And it's really hard to find. It's really hard to find people, and if people in a small area are turned off by you for whatever reason, then like like it's a little bit harder to find new people who want to give you like a completely fresh start, or like like, and sometimes it's just nice to know what people like would think of you if they didn't know you. Um, so anyways, what's I gonna go to? Let's see. Great. Lost my train of thought. Need more structure. So I'm gonna create the drum kit, like sampler, miniature. Oh, shader toy. That's what it was. Okay. So I want to make an app that like both allows users, probably just me individually, to create like drum loops, like MIDI sequences of drum loops, and and also allows them to upload sounds and like bind sounds to like drum kit like samplers, and then like you'll basically have like a feed and you just like scroll down the feed, or you can get it to auto scroll for you, and like samplers that people have made will like play the same drum loop that you've got configured. So you have like 4 bars or 16 bars of like drums like playing, and you're scrolling through like your like browsing through your tweets, but you're hearing sounds that people have configured for samplers. And I mean, this is how I wanted to restructure like the Oscillate app that I was working on for so long. Like I started working on that app in like very late 2011 and like very early 2012, and it had been something that I've been milling around in my mind since October 2011. And like I saw the opportunity, and just I was like, hey people, would you like to would you like to build $100 million company? And they're like, that guy is, you think he has a Steve Jobs complex or something. Like, he's a entrepreneur. He's not an entrepreneur. He's not going to be an entrepreneur. He's not like, I guess, I don't know. I feel like, I mean, I did drop the ball kind of a lot. Like, I have, at certain periods, dropped the ball kind of a lot over, like, years of my life. But anyway, so this app was exactly like Splice.com. You go to shadertoy.com. Splice.com is like the place for like music producers. Is it Splice.io? It's like the place where music producers across the internet like collaborate on music. It's basically GitHub for music. And it is like one of the reasons I wanted to like work on it was I was like, I don't want to just like work on something that's like a boring business. I want to make sure it's creative, and I want to make sure that it's like significant in like how it like changes something. And I really like music, and I'd actually ordered a bunch of music equipment. Then ran into the problem where like I couldn't like maintain the configurations and like make sure that I could like back up things easily. And then I was like, wow, people could like share these things on the internet, and it would make it so much easier for you to learn how to use like kind of obscure pieces of like music equipment, because you could upload like hardware configurations instead of just like, and not, you could not only upload software configurations, you could upload hardware configurations. And then and so anyway, and I knew that it was like the kind of idea that like somebody's gonna like, somebody might take that, or somebody might just think of it because it's a good idea that someone's gonna think of like eventually, and they did in 2013. And like Splice came out in 2013, in October 2013, I think. Yeah, and so because it was after the Rocky Mountain Ruby, but it just like it's basically GitHub for music. You can upload the songs that you're working on. You can work with producers across the world. You can work with people who have like the same equipment as you, and so you can just like move the files in and out, and like have like the same virtual like soft environment, like being like loaded into 2 different like music studios. Of course, that doesn't usually happen, but then also like people can like work together who have different like sets of music equipment, and so you could like use your like use your friend like from like, say he lives in Las Vegas, you can like, and he's got this like this like array of like Moogs, and then like some like just daunting like analog synthesizers, and like you don't know anything about that, and you can't afford like a Moog Voyager or like a Korg or something, and that guy can just like mess with the sound, and then like record samples, and then add it to the project. Of course, that kind of like, once you digitize the sound, everything from there on out is like digital. Anyway, I knew somebody was going to take it eventually, and the product went through a lot of different phases, but I could not whatsoever like get anyone to like. So it's like, it's not just like somebody's like, you want to make $100 million? Like, I mean, sometimes we use that kind of pitch as a joke, just kind of like pique somebody's attention, and then make them maybe think that like, like make them kind of like question it immediately, but then like within like 30 seconds, like immediately follow it up with like, oh no, this is gonna happen, it's real. Like if it's not me, it's me. Somebody else's $100 million company, which is what happened. They're worth, I think, about $100 million. I don't know. I tried to estimate it. Like their finances are not all in the open, but or the last I checked. So it's difficult. You have to like infer like who owns what of like which round of like funding, and then like just kind of gauge like maybe like what the valuation was, and then like, and it's really easy to get that wrong. But it's now like the idea is now a thing, and it's really cool. But in response to this, I was kind of bummed out when I first saw this, but like I knew like I had kind of been prepared for that, and I was bummed out that I just couldn't find anyone fast enough to be able to work on it. And like to me, it was like an easy sell. It was like GitHub for music, GitHub for music, like 3 words, GitHub for music production, maybe 4 words. I don't know, like. It's like, yeah, I mean, like why not? And then I also realized like exactly what the DAW like designers were gonna do. So the designers of like digital audio workstation software, like each of them, like I kind of had, I don't know, I feel like I understand their like tendencies like in the music like industry, but I really don't know. Anyway, so I understood what the DAW manufacturers were going to do, which was to like create their own like walled garden like of online stuff. Which people who are going to collaborate on Splice, like you're going to see like a, if you mapped like if you looked at a map of like the projects that people work on together, and then like the digital audio workstation that those people like use. Just like you would look at GitHub repositories and then like compare it to the primary like programming languages that someone used, and look and identify correlation between like the people who use the same programming languages and the people who like work on projects that use that programming language or work on any project, then you're going to find that the people who work on similar projects generally use the same programming language, because the project normally only has 1 or 2 or 3. But anyway, the point is like the DAW like software designers would eventually kind of screw themselves by trying to implement everything for their online system. And I think Ableton's doing all right with this, but they would try to like block people in and do certain things that people wouldn't like, and then it would like result in a like inherently weaker network. So even if you got these like shards of like user to user connection, where like each shard represents users that use like a specific digital audio workstation, like even still like the platform as a whole, if it is whole, like brings value in that like you can still connect to the other people who use the DAW, and you can still see what they work on, and you can understand like, oh, they did that with that software, and wow, that's pretty cool. That was easier. That like, I really like that. Or like, there's a new feature and I wasn't aware of it, but like this project came by, and I don't normally look at those DAW projects or projects for using that DAW, but I glanced at it, and then like, wow, they've got like a bunch of new features, and wow, this is in the free version. Like, I'm gonna like switch. So those are things that like the digital audio workstation manufacturers wouldn't want. But wouldn't be able to stop, because in the end, like people are going to go to where they have to where the value is, and where they get value from using this stuff. Because anyway, so I was kind of bummed out when I saw it come out, and so I was like, what am I going to do now? And I had already been milling around like a kind of a backup plan in my head, or it was like really kind of like a pivot that I was considering, and Splice has done this as well, because this is the business model for this like niche. Like this is what you do. This is the answer. There's an answer. This is it. It is to like create a store for like purchasing samples and drum kits and software instruments and other things, and it allows people, like what it does is it incentivizes people to use your platform. And what's valuable is not the money that you collect from people using your marketplace to buy things like that. I mean, money seems nice, but what matters is how much time somebody spends using your product. That's the only thing that matters. How much focus times time that they grant your product. And if you have that, uh, you've got something that I guarantee somebody is going to be willing to pay for. And so if you have that, you're good. And like, so if people are incentivized monetarily to like use your platform to create things that they can then sell on your platform, then that is like, so like, that just like perpetuates itself. I mean, it's like self-propagating, I guess. But and I don't know what the numbers are for what they like, what they did with it. And I'm not trying to say like, oh, I invented it, they took my idea. Like, no, like this was gonna happen, and like I'm like, it's just like I don't even understand. Like, it seems like a no doubt pitch. Like, do you want to work on this, and like not only make $100 million, but become like the most important influence for networking like up and coming musicians, and for like helping like professional musicians kind of like exhibition like certain things that they do with like music production or like $100 million, or like I get to like be very influential in the music industry. Oh, I get both. Right, I forgot. And like no one takes you seriously the entire time. And like it's like, no, but I have patentable ideas and all this stuff, and people are like, sorry, I'm not trying to be like a downer about this. Okay, so shader toy. I want to build something that's kind of like a cross between the pivot that I wanted to do after Splice came out and shader toy. So I wanted to focus on the marketplace aspect of like sharing instruments, and then I was like, so what is the minimum viable product for that, or what is like the minimum? What is the first step for like kind of getting something on the web, trying to like gain a presence, trying to like have something to show like angel investors, and I wasn't somebody that was going to go for VC, but like having something to show somebody to like develop like confidence in my product, confidence in my project, and like make it just dead simple to explain what it is, what it does, and like it would be very interactive. You just go and like click on things, blah blah blah, and you want to spend time on the app. It's not just like, oh, this is what the app can do. Oh, okay, that's cool. It's like there's something engaging that like pulls you back, which is actually why while I work on this app, I'm gonna add in some. I've got a feature in here somewhere. I'm gonna add in a. I'm gonna add in Google Analytics into some of the like audio components just to like get like develop counts of like and other things. Although I'm not sure if Google Analytics is really the best place to do that. I mean, I'm gonna do some like I'm gonna integrate Google Analytics in there somewhere. But I gotta think about that because it might be really dumb. Anyway, so I want to cross that pivot, which is like the minimum viable product that I was moving toward, that I wanted to move towards, was like one where you create samplers of sounds that you've made, and you have a feed, and you scroll through the feed, and like it plays the same MIDI loop on like through each like sampler. Now I just kind of want to do it for fun, but I also want to make it so that like while your feed is like pushing the samplers up, if you've got it like auto scrolling, or while you're like browsing through the feed, you can trigger like visualizations, like audio visualizations, and I want to try to implement something that's similar to the floating like video player from Facebook. So I want like a floating visualizer canvas, and you could like make it larger, and maybe it docks into some of the other like components, and then you can like also move it around. But the visualizations could draw from like a standard set of visualizations, or ones that I created, or or ones that other users created. And I mean, there's no real point to that. Like, there's no business model. There's no, like, I don't really care. I just want something like that. And Shader Toy would work. But the thing that Shader Toy doesn't do is the thing that I'm interested in. This is the thing that like no one does. And like almost everyone still uses WebGL 1, and they use 3JS or A-Frame, which uses 3JS, and 3JS is a library. And there's other like graphics engines or game engines out there. 3JS is something like between like a graphics engine and a game engine, although it does resource management for you. It does it does like a basic level of like resource management for you. Like it manages like the buffers you create, the textures you create, and stuff like that. It tries to like make the like code for generating textures and creating buffers and encoding buffers and encoding all the commands for like programs. It tries to make all that like as simple as possible. But ultimately, actually, there's you can only compress that to a certain degree. Because like you just can't remove some of the complexity, which is why it's like why I prefer to use like a small thin wrapper around the WebGL framework. But I do love A-Frame, and so I want to see if I can get 3JS to or I want to see if I can get A-Frame to coordinate through 3JS such that like I can instantiate objects. 3JS can manage my 3JS and A-Frame can manage my scene graph, and then I get to tell it like how to encode those objects into the draw calls, or yeah, so that I don't have to worry about the scene graph. That sounds great. And A-Frame is awesome. Like it does the exact kind of thing that I want, which is like if you view the source, like everything's declarative, but it's a declarative scene graph. It's not like I want a declarative declarative render pipelines, and just like because there's a lot of like cruft there too, and 3JS only really has WebGL 1. A-Frame uses 3JS. Like, so I'll just reemphasize that. 3JS does provide you access to a WebGL 2 context that is somewhat like distinguished from the WebGL 1 context, but it doesn't, like, none of its scene graph features really encode things into OpenGL 300ES shader code. So that's OpenGL, like I think it's equivalent to like version 3, I think. Whereas WebGL 1 is written against OpenGL like 1.2, I think. And there's a really big difference between those two things. Like there's just certain things that you like and everybody uses WebGL 1 because if you write graphics code for a browser, it's almost certainly not going to run on somebody's phone if you wrote it with WebGL 2. Which for me, like that's just how it is. But for a company like Google, anytime they do like demonstration type products or demonstration type like projects that show off these graphics frameworks, they're going to use the one that runs on mobile, and so is almost every person. So I want to actually support both, but and there's a lot of nuance to that. But I'm not going to worry about that at first. I'm going to worry about that once I start tackling the mobile aspects of everything, because I don't care. I just want the thing that like makes it easy for me to build things, and just like I don't know. I'm just frustrated. I'm like kind of tired of like not like being able to like I don't know. I want to be able to like easily show people like what I've built, and just like mean, a lot of that's like, a lot of that is like my fault. And I like, it's really just the impact of like, I could have done myself a lot, you know, a lot better in my approach to these like projects, but a lot of it is like not having enough money to like physically make it to events where there's like people that like really understand what I'm talking about. And Blacksburg has some things like that. Roanoke does a lot. Um, it's just like I wanted to be really, really, really good with programming. I was like, this is this is the thing I want to do. This is it. I don't care about anything else. Like I kind of like had given up on jam skating. I would float in between jam skating, blah 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 blah. And I felt I was really good with jam skating. And I was like, you know what? I really like tried hard, and like now that I look back, I could have definitely like structured my practice a lot more. Like I could have worked a lot smarter, and I just didn't even think about it. But I wanted it, and I remember that I wanted it, and I invested a lot of time like practicing skating and doing what I love, and it made it made me happy. Like I enjoyed doing it. But anyway, I wanted to do the same thing with programming. Like okay, like I want to be like the best programmer ever. Like I mean, I obviously knew that would be impossible, but I mean, I wanted to like why not try hard? Why not? Is that like that is like in my opinion like one of like the worst like insults because it is kind of funny. I guess like at the surface you're like it's try hard. Yeah. But who like chastises somebody for like trying hard? Like who does that? And like no, I don't take it personally. Like I've been called a tryhard once or twice, but like it's never like really stung because I don't understand people that would say that. I guess I mean I do understand kind of what they're saying. Like, geez, dude, you might should try a little hard, like try a little harder doing something else. Anyway, but I don't care. Like because I mean I like my mind. I realize I'm creative. I enjoy being creative, and I enjoy thinking. I enjoy like I don't need success. It would be nice to like have some success as like to like pace like how I feel like I'm developing in terms of like my skills or and it's just so easy for me to like stagnate and then kind of become like depressed because like I don't get any feedback on anything I do and it just wouldn't matter what I did, people would treat me the same way. Or I don't know, but and I've had that in other areas. I'm not sure where I was going with that, but anyways, I'm like sidetracking and trying not to do that. So A-frame does like scene graphs basically in web components, and it's front end framework agnostic. They wrote it in web frameworks or in web components because so that it like the same like language, the same like libraries could be used. So the same libraries can be used for React and Angular projects. Uh, and so I want to do something similar, but probably not in web components, not at first. But I want to like declaratively like create like render pipelines, and this is like that's exactly what I was doing with Spectra in Swift. Except I spent I finally realized with Swift like I can work on this like this graphics library that I didn't want to build because I wanted something like a little bit more lightweight and a little more low level than like Apple like most of Apple's like libraries. I was more interested in doing compute than graphics. Um, I was like, I can spend all my time working in Swift, but until I push an app out, it means that nobody can really like experience what I'm doing. And so that's one reason I started live streaming because I was like, I'm doing all this stuff, and it just seems like people aren't recognizing things that I'm doing, or they like I don't know. And I don't communicate. Yeah, like I don't communicate well about that, and I tend to like have my head down working like, or trying to work, like wanting to work like all the time. And then like in other areas in other cities, it worked well because I could go to a hackerspace and like there would always be like, you know, at least like a flux of like, you know, 5 or 6 people that were like very technical, very like in their own direction. Like at any time that like I went to the hackerspace in that area, and I just like the people that I met that would come in and out, work on projects and stuff, they completely expanded my mind in terms of like understanding like what it was that like can be done with computers, electronics, like materials and everything. And I was like, oh my gosh, these people like know so much more than I do, and they can completely open my eyes to everything. And like I loved it. Like the hackerspace in Virginia Beach was 757 Labs, and it was just amazingly fun for me to go there. I really missed that place. I not want to leave, but they had so much cool stuff. They had some pretty cool pinball machines. They constantly had meetups. There were constantly people in there working. There was a guy that would like fix like keyboards and stuff, and like, you know, like I'd never really seen anyone work with electronics in that way. So like he was like tracing the circuits, trying to figure out like what was wrong, and he had like bought like a keyboard on like Craigslist, and like it's a gamble. Like sometimes it's easy to figure out what's wrong, sometimes it's not, and it was just like interesting because like I would go to this atmosphere and I would just like absorb knowledge, and I would like, and it really expanded my mind. It like allowed me to like it allowed me to develop an appreciation for like learning for the sake of learning, and then like I like saw a place where like so many people could learn very quickly, and that was kind of the focus, was to like allow people to develop their skills, or to develop skills in technology. And I was interested in technology, but I never actually like had that moment where I was like, you know, like where I realized like how much harder other people work on technology and work to learn stuff, and where I realized like like how little I knew, I guess, and I would constantly realize how little I knew, and I never really I don't know, I just never really had like even conceived of a place like that where like, you know, like I could go hang out and like everything would be positive, and like I could just kind of like talk about things that were interesting and challenging for my mind, and I was constantly like learning things, um, and that's one thing that I've wanted in Roanoke for so long. There have been like some hackerspaces like that come and go, but I just never like I don't know. I've looked for them at times, like, and then like they would have a website, and like I would try to call and I would try to go there, and like it wasn't there, and like it's really frustrating because like I want something like that. I basically have a hackerspace in my basement, or like a, you know, very small hackerspace, like, but I'm still like there's just not enough like people in this area that like, I don't know. And like I feel like I'm very intelligent, but I've still got so much to learn, and like I know I can learn so much faster, and I know I have like confirmation bias, and almost like Dunning-Kruger, I guess, where like it's like when I work on when I learn new things, like new like frameworks, or learn about new libraries and stuff, like it's almost always new to me because like I found it. Um, Sometimes people introduce me to things. Sometimes people will introduce me to like some like list of like links for like, you know, web audio frameworks, or web audio projects, or web audio resources, or sometimes like somebody will introduce me to like um, something like Swagger JSON. Like I didn't even hear about Swagger JSON or Open API until like maybe, I can't remember if it was like in 2018 or like maybe summer 2017 or summer 2016. Like I just never heard of it because I have no contact with people. Like I'm saying, like I'm isolated. Like I don't I don't talk to people about anything I do, which is why like I don't care that like I would try to write as much as I can and try to like live stream when they're fairly esoteric like things, because like I just kind of want to put it out there like, hey, I'm the guy that like really wants to learn things. I'd like to learn things. I'd like to change the world. I'd like to like, like build something. I'd like to help teach other people and help like, share some of the knowledge that I have. Like when I was growing up, like, and I was in like middle school or high school, like that was the thing that was like considered good. Like like if you were smart, like doors opened for you. Or I mean, if you were a good person, doors open for you. But like if you and like teachers always seem to be like impressing like upon their students like the goal or like the idea or like the incentive to like want to learn for the sake of learning, to want to like appreciate like the subjects they were teaching, because like out of a like uh, a desire to just like kind of, I don't know. They would always try to establish a connection to their students, like hoping that their students would appreciate like their subject or learning in general. And like the idea was that people should want to learn, and it's just not there. Like that's how it felt. Like they presented it to like students in my high school, was that like they didn't literally say it, but they were like, like their actions implied that like people believed that like it was difficult to get students to care about learning, and this is a problem. So if you care about learning, that's a good thing, because there's a lot of people out there that don't really like don't really put in the effort, or don't understand like how useful it is like while they're growing up, and then they don't have a chance later. And I guess maybe that describes me, but I just don't understand why. Like I don't expect somebody to treat me like I'm like a junior in college or anything. Like, but at the same time, like I would like to learn. I would like to teach people. I have a lot of things to teach. Um, a lot of skills. I've got a lot of and but then at the same time, I find myself like I almost instantly repelled from like any like social atmosphere that like I'm in for like the period of like a month or like a month and a half. And maybe not, like no one ever does anything so directly. It's just like like adults, like day by day, week by week, they're like figuring out who's going to be on their kickball team, basically, and they pick the people they want to be on their kickball team. So like nobody like makes the decision to not add you to their kickball team. They find the people they want, and they only need like they can only really manage like connections to so many people. But just like I find my like resume at the bottom of every stack, like to be like to have like 100 resumes, like mine just right on the bottom. If it like doesn't get deleted, or and like I understand that like I can't expect like everything in my career to be fixed instantly, but I think it's ludicrous that like I've been like unemployed for the periods of time that I've been unemployed. Like it just doesn't like it's almost incomprehensible. It doesn't make sense. Uh, and it's this like self-perpetuating problem. Like I can't move to another place because the transition is often like a little bit too much stress, and so like stressing out about all these like things, and I get there, and then like normally, like, I don't know, I don't want to talk about that. Anyways, I want to build something, and then that way, like, it says, you know, I mean, it speaks for itself. And there's been a couple projects that I've like built to like a prototype level, but it's because there's like nobody giving me feedback and nobody like patting me on the back and nobody like saying like, wow, I'm impressed with everything you've learned. I don't understand it, but I think that's a really good thing. It's a really good thing to like value knowledge for and like to really like pursue like the acquisition of knowledge. Like I don't expect anybody to like say that to me, but like is like it's only like there's got to be something out there. So, anyways, sorry about that. I guess. Okay, so A-frame comes with like I think an inspector, and so I'm going to use A-frame. I'm going to kind of like I'm going to do this on my own time, but I'm going to kind of dissect how they've got the components like set up and just like see exactly where I can use it. And I'm basically just going to need like a texture, like a 2D texture, and like maybe some structures to keep track of like particles and particle properties. One of the features that I want to use and that I will probably actually use to bridge A-frame 3JS to to like my own library, which I'm calling Pipe Dream, since it like declaratively specifies rendering pipelines. So I'm going to bridge the gap between A-frame and the Pipe Dream library with at least partially with like vertex transformation. So like 3JS will put stuff in pretty like plain, like uniformly structured buffers, but you can't do things like vertex access objects. And since I've walked through A-frame, or at least demonstrated A-frame, I'm just going to go on to reviewing the WebGL API. And then I'm going to take a break, probably around like 1 o'clock, get back on at like maybe 1:15, and actually generate the Loopback app. And I just want to have like a break in the videos so that the first thing that somebody sees is me generating the app and getting to work. But I like talking about these things, and I pursue tangents because like I almost can't resist it. Just add another tangent to my conversational stack frame. But anyway. Oh no, Stack Overflow. This is probably not funny. Alright, so it might be if you're a programmer. This is just not even gonna work. Alright, so I'm going to do some magical keystrokes. Where'd they go? Like I configured Firefox so that I could keep it in the region of the screen that was like off screen. Kind of did a lot of things. Basically to make it so that like I didn't have to really assert whether or not like I would accidentally trigger a screen transition that would display information I want to display. But I just use one monitor. I guess that's what I'll do. That's a lot simpler. All right. So this is some of the WebGL. This is the WebGL 2 reference guide. So when I say I want to use the vertex transform feedback as the bridge between A-frame and my own library, that is described down here. The transfer feedback is kind of like a complicated thing to use, but basically you have like, it's like almost like you get another layer of a vertex shader. So you can run a vertex shader, and then you can get that vertex shader to output to buffers. Although it's kind of a pain to get it to work, but then you can take that and run it on another vertex shader, and then like the rest, like then it runs the fragment shader. So you can work so that you can do like operations on buffers as like sets, and you don't really get as much like parallelism, I guess, out of the GPU, because you're working with like small structures. They can't be as easily like parallelized as like operations on and writes to color attachments and textures. But it still saves you a lot of time. And I guess you could just like tell JavaScript to like move large amounts of memory outside of it. But I want to use the vertex transform feedback to take things from a let's see, vertex array, is that what it is? Vertex array object. So I'm going to define vertex array objects, or define the structure for vertex arrays. And that's like a kind of like a memory layout in the buffer. So a buffer is a large like array of linear like memory, and you can say like how much you want like each like indices or index of that like buffer, like how much memory you want each like thing that you're storing to be, and then you can also tell it like how much you can tell it how much you want the you can define a structure like using like patterns of design that are similar to those used in C programming. So in C programming, you can just magically take things from like being one class to another class, and all you do is say like, C, give me that like, well, of course C doesn't have like classes natively, but you're just like, C, like give me that object for memory, and like take the memory structure and do this, and now you have this object, and C doesn't really care like that it is that object or that it isn't, and you can manipulate it, write the memory stuff to memory, and then like have like something else pull out like a different kind of object for memory, and then it's like a different thing. So I want to take these like uniform representations of vertices from Three.js, which should be pretty simple. Like it'll just like initialize that stuff, and I'll just use vertex transform feedback to like mutate the state a little bit, and then like add in other properties from other buffers, and just like map the structures to the actual like vertex array object that I'll pass to like my GL program with the vertex shader and the actual vertex shader and the actual like fragment shader. So and then it runs. And so that's kind of a hacky way to get around like mucking in the internals of A-frame and 3.js, and I've looked into these like graphics libraries kind of a lot. Like at one point I'd like forked the WebGL like inspector, and I was starting to try to like make contributions to that project. It was a little bit out of my scope, I guess. I mean, I could kind of like I could get it, but it was massive, and it was kind of difficult to like parse. But that's a really good way to learn about graphics. That's probably like the #1 way. Like if you want to learn graphics, like the best way for you to get really good, and I'm talking about low level stuff. Oops. The best way for you to like instantly gain a lot of skill, and I'm all about this stuff. Like you accelerate your learning. But the best way to get a lot of skill quickly is to find a project like this on GitHub, and then find a graphics library debugging tool on GitHub that's open source, and then just like try to do something, try to add a feature, try to fix a bug, like look at the issues, try to respond to the issues, um, and just like see what it needs, see what it has. And with WebGL Inspector, it needed a lot of work to for it to like handle the new features from WebGL 2, and like to fit like other products have like since kind of like fit that niche. So there's one called Spectre. There's like several of these projects, and A-Frame has something similar in it. But the reason why it's so good is that like there's no like bouncing around from like documentation page to documentation page. Like, nope, you get to drink from the fire hose. So like they just give it to you all at once, and you like understand how the the WebGL framework can like facilitate like querying its objects, and like and you get a understanding for how WebGL like keeps track of resources, which is stuff that you don't normally need unless you're doing a lot of metaprogramming with graphics, or unless you're writing like a tool to debug graphics. And one thing that I loved about Metal and Swift was the debugging tools. I mean, it's just fantastic, and like there's certain like features that are going to be very difficult for other like hardware manufacturers to implement with Vulkan. Like Vulkan is like pretty much the same like software like idea like behind as like Vulkan is like built with the same like design motivations as like Metal. Um, but Vulkan is built for like just generic hardware, or for to run on almost any hardware that permits it to be used, that has like drivers that will allow Vulkan to be used. Um, but Metal like can like really simplify a lot of the like tougher design problems around graphics programming, like where you have to worry about like homogeneous like hardware, homogeneous architectures. And that just means like you have to worry about like somebody having a different CPU and somebody not like having like a CPU that's capable of these features, or like or you have to worry about like situations where like somebody's like graphics card can only do 8 color attachments, but like your program needs 16, or like you weren't really like as advanced with graphics like programming to understand or anticipate like how to like handle how to change like the flow control of like your main render loop like monadically, so that like it would like restructure like the draw calls and the sequencing and draw calls so that it could take advantage of the graphics resources that are there, or deal with like limitations of the graphics resources. So like dealing with situations where you have like fewer like color attachments than you would like. And a lot of people so if you're working with Three.js, like there's just like kind of a standard set of color attachments that you need, and you might like double up on those like color attachments, or you might like add a couple here and there. But if you start touching color attachments with like a graphics engine, then you're like getting yourself into a lot of like a lot of work, and like it can be difficult to restructure the logic of programs. Like if you're doing a lot more um, like custom stuff like that is like mixed in with stuff that Three.js like already does, then you can kind of like if you decide that you need to change something later on, it can be a lot of code to write and to deal with. But not necessarily if you do things declaratively with like XML or web components, which is what's amazing about the A-frame. And so like for me, the library that I built with Swift was like something that built like something that like something where I wanted to apply the ideas of Angular's like implementation of dependency injection to like the graphics pipeline resource management of a like graphics engine. So like hey, like graphics engine, I need to make all these like resources up front in the startup time, and then like once like the program's initialization is ready, I've got like the ability to draw on like and pull and like dynamically like connect together, almost like a series of pipes or a series of tubes or like uh, that's a really bad like attempt at an Al Gore joke, um, but I just wanted to be really simple. Like these are the types of things I need, and you know, if those specific things don't really work, then like let me define some things that like provide like monadic like a monadic method for like fetching like an object that's just like that one but slightly different, or which can be kind of unsafe with XML. But again, I was using it for kind of like my own purposes. Anyway, and in the browser, it's fairly secure. But like, I just want to like get those things, like put them together, and then have them ready to go, so that you put like data into the like the top of the pipe, and then it goes like through like um, it's like processed to the places it's processed in the places it needs to go. And I just kind of got bogged down. I didn't make enough progress, but I'm kind of excited to try to do something similar with WebGL, so that and it's not as exciting as with Metal and Vulkan. Um, and it's still a little bit hard to work with. Like apparently they took SIMD instructions away um, from the browser. So and that just means like with SIMD instructions you can operate across like uh, matrices and vectors as though like it's just one operation. So it's not like add or whatever. It's just like CPU is like, wow, okay, that's a matrix, and here's another matrix, and we're good. Just one instruction, and that helps like when you're shifting, like when you're using the CPU to shift around lots of like when you're using the CPU to shift lots of data around from buffer to buffer and operating on uh, data that's stored in buffers. But it just also like generally it helps like if you want to, I don't know, it helps kind of a lot. And you can use SIMD instructions in the GPU as well. Um, but that's coming in WebAssembly, so like they're just kind of like pushing it off and like enabling it for WebAssembly. And another thing that I found that is kind of like the like it's like how you drink. Let me put my like streamer thing. Another like method that I've kind of fallen in love with is oh wow, that's the wrong screen. Okay, wow, sorry guys. That's why I need like another monitor, but my graphics card is just like not like you can barely keep up with like what it's got going on. So I wanted that extra space on my screen. Okay. Anyway, so what I was talking about earlier, there were I want to use the transform feedback objects, the transform feedback feature to pipe data from between 3JS buffers and like the buffers that my pipeline framework will actually use as a basis for like the vertex shader to pass this out to the fragment shader, and as long as I like, which is kind of that might not play out well, but I think that's like the smoothest, like simplest, like interface, like point between like the two like different methods of doing things. Like you got 3JS's like kind of like simplified but comprehensive like functionality, and the vertex structures are like pretty simple and like obvious, and then so you can store some values in there, and then you just like use the transform feedback feature, and you can like braid like multiple buffers together, and like just kind of like it's you would be like treating the data that's sent into the new buffer almost as though it's like immutable. I guess, well, actually, you can't. That sucks. I like that. I think, unfortunately, I think that's the simplest way to do it, and it's not really that hard because there should be some fairly simple way. Since like 3JS is like buffer structures are like fairly consistent. That's the easiest way to do it, and that will allow me to like easily add in the features that I need to without having to like worry about like all of the surface area of like 3JS's like API. So like I don't have to understand all the parts of how 3JS works, and I have spent like kind of a significant amount of time like digging into the internals of that like a year and a half ago, um, and I just know that I don't really feel like doing that. It does things that I like, and I wanna drive the car. I don't want to know how the engine works. So I want to use the interface, and I have to figure out how to something to bridge the data to like the functionality that I want to build. But it's mostly so disparate from what 3JS does that it if you try to do it within like the language and API of like 3JS, it's going to be like messy because you're going to have to like tack on things here and there, and like you don't really want to extend the objects, like especially if you're like building a library for doing this. You don't want to like subclass like 3JS classes, and you don't want to like, and it just like turns into kind of a huge mess where you have to really like, like think about how you want the design, like what's like, and then but if you just like bridge the data out and it's just as simple as like transform feedback, now operate it on it as normal, and then maybe like pull data back into 3JS and update those buffers, which that could be become kind of complicated, or that could introduce race conditions or like timing issues, and but I really want to know this stuff because like understanding how this stuff works at a low level like has helped me like anticipate like what I think will be possible with like VR, with like mobile computing, and with machine learning in mobile, and machine learning like in consumer hardware, um, because this is really the nitty gritty. This is like how like that how that stuff is gonna run, how those operations are gonna run, and then understanding all those lower level like building blocks gives you an idea as to how people will approach building software for it. And some things will be too complicated, and so, like some things are not. Um, but having a unified like set of hardware to run like compute stuff on, or being able to like really restrict the space of like hardware and like design variation, um, really gives Apple a leg up with Metal. And like for example, like software developers can develop stuff that takes advantage of the different shared memory modes for the GPU, and they can do that, and they only have to worry about like a couple dozen like sets of hardware, like that all have like an even more limited like variation of like uh, you know like chip like structure and like the chip pairing and stuff. So there's a restricted like set of like CPUs, and I don't really know like the name of. I guess it's like that. I don't know the name of the CPU in my iPhone anymore. Like I used to. I guess like A7 or something. But which I guess makes it sound like I don't know what I'm talking about. I feel what I'm talking about. Like I can't like. I'm trying to learn how to like describe it, and that people are like, what, like, you know, it's weird, or like, you know, you need to take a public speaking class, or like, you know, like, and I understand that, but like I absorbed this stuff, and I'm like, I've wanted to do something about it because I want to be able to like demonstrate what I know with math, and I'm interested in like economics and finance and learning these things, and until like the best way for me to learn, uh, and one of the best ways for me to increase the like retention of like what I learn, and to well, the best way to do all that is to work on a project, and then I can communicate it to someone else without having to like try to tell them about it. So I don't get stuck with like my communication problems, like failing because of like certain things, which like aren't really like, you know, they're like my own issues or whatever, and it's not like it's not that bad. But then like, but it's difficult for other people to see how they actually impact me. Um, and it actually shouldn't be that bad. I just have to like have some like healthy like normative like social influences to like, you know, like when you don't have those like normative like when you don't have the normative the unconscious normative like social influence of just like meeting new people and like having to think about what they think of you and like trying to like be like like let me like not do weird things like what like I don't know like just like that. um it's weird like I mean Tom Hanks like ended up talking to a volleyball like and it's not actually that bad for me, but it's just like it's so simple. Like if I'm around people, like I'll have to constantly like, you know, think about like when I'm at home, I can just like walk around in like running shoes and shorts all day and like not really care how sweaty my shirt is and like I mean it's just like things like that like. And like I can see the problems. It's just like there's not a lot of like not a lot of ideas as to how to like fix them. All right. I think I'm almost done talking about WebGL for now because it's like kind of heavy. Uh, it's kind of like very dense. Uh, and I'm actually not going to get to doing WebGL stuff until after I do the WebAudio stuff. Oh yeah, yeah. Let me get back to Trello. And when I start streaming, I guess at about 1:15, I'm actually going to be writing code. So sorry if you expected to see something. I'll add some notes in the description. But at that point, in the second part, I'm just going to start running through code as quickly as I can. I was just kind of exacerbated because I wanted to schedule my stream and then I kept having to push it back and then like I thought it was ready and I fixed the resolution so that I could have 1080p and like not have to worry about like the like the computational load of the render or the encoder or whatever. Like if you like just have like a texture and you operate on that texture, or I guess you don't do that for rendering. But anyway, like if you keep things like if you keep like things at the same resolution at various steps in the streaming process, then like you don't have to re-encode and you don't like sacrifice video quality and you don't like have to your computer doesn't have to keep computing thing, and then that screwed up my scene thing. And like, this is why like I don't understand like I just want to like I don't understand why like I haven't been employed. I don't understand. I mean, I know I've been through a lot, but I don't understand like I don't know. It could could have been a little bit stronger about it. It could be like, I don't know. I just don't understand like how somebody like me would spend like the majority of the last like 6 years like unemployed. Like, it just doesn't make any sense. And, I mean, I've made mistakes, but at the same time, like, okay, so like one of the first things I want to do, I don't know if I'll do this first actually. So I'm gonna take Swagger JSON and convert it to UML diagrams and just kind of produce like some like API documentation. Or just some API like diagrams, and this stuff like really helps out a lot. So if you have like, and this is just basically like if you want to learn like a comprehensive like set of like APIs at like Mach 4, like it like basically as fast as you can possibly internalize the information. Uh, this is probably like this is my best bet for like making that happen. Like, so if you want like Microsoft like Azure like cloud has like there's like 70 or 80 APIs. Like they have stuff for like computer vision. They have something called the service bus, which is like a like giant like system of queues in the cloud. So you just create queues and like take like jobs from like one. You can take jobs from I guess an on-premises network or a network that's connected from like a network that's connected like through to Azure through a VPN or connected to a REST or HTTP service that it can like securely make like outbound like requests to. As long as it can make that connection either via HTTP or like via HTTP using the VPN connection, then it can just like create like it can send the data to the worker that the worker needs, and then or yeah, the workers can like pull the stuff from the service bus. I think I screwed that definition up, but anyway, the service bus like uses there's like some Java examples for working with it, but it uses the concept of like futures, which are like contracts in Java for like asynchronous programming, and I think you can also write stuff with like C#. There's not really any other examples for it. Those are like the only frameworks that like I think facilitate writing code with that. But like if you just want like applications to have like the ability to like securely create jobs, even though they connect through like on-premises, like from on-premises networks, or to like collect job definitions from like the service bus, either through the VPN connection or not. Then you kind of do that, and you give them the data they need, and they like do the operations, and then like return the result. And it can process like large, like so it's very like easily like scaled and dynamically scaled. And then there's one called another really good like API to learn if you want to learn like about how Microsoft does pretty much everything, like represents like all the systems that are stored in Azure. Like a good place to start is the Service Map API, which like defines like it defines like all the different kinds of objects that can be like represent. You can pull down like network diagrams basically, or you can pull down data that allows you to easily construct like graphs of like that depict network diagrams. So if you want to like programmatically generate like documentation, or if you want to programmatically like inspect your network, and like for some reason if you're working with like software-defined networking, like over top of the software-defined networking that Azure provides, then like you'd probably use the Service Map API at some point. And I mean, Azure does a lot of really cool things. I'm interested to see what Google Cloud does, because I haven't worked with Kubernetes, but I've heard a lot about it, and I don't even like really remember what it was, but like back in the days when I was trying to work with CoreOS in the cloud, I couldn't afford like a single EC2 instance, but really wanted one, and like was just hoping that like DigitalOcean would hurry up and like release the thing that I could afford. Please, please make it for me. I don't have money. But anyway, back when I was doing that, like Kubernetes seemed like it would be really cool to learn, and I haven't done enough with Docker. Um, yeah, okay, that's what I need to do. I need to get like a Docker image like set up or something. That's what I'm meant to do. Even though I guess I'll be using like HyperKit on Mac, but there's just like so many technologies, and these are like things I don't know anything about. I haven't had any conversations about like any of this with anyone basically. I mean, Microsoft stuff, yes. Like, I mean, that actually that aspect of my life that I complain about all the time completely changed over the past few months, which was wonderful. It was amazing. Like, um, but anyway, so there's a bunch of other Azure APIs, and like they're all kind of daunting to look at first, or to start to piece through. Um, but I mean, I pretty much understand like at least the high level like purpose behind or motivation behind like uh, the APIs that all the APIs that are on there. I mean, and like I'm interested to see how like Google tackles the same things. I mean, they're all like Google, Azure, and Amazon are all kind of like working like to solve the same problems, and that's why you get things like PKG Cloud, which is like a cloud agnostic. It's a cloud agnostic uh, library for Node.js, so you can like it basically generalizes the kind of operations that you can do. So like libraries can be built uh, over top PKG Cloud, and then you just tell it what service provider you're using. You just tell it like what cloud to use, and you can mix and match clouds if you want. Um, so like if you want to learn like great open source projects to like get up to speed, and I'll finish like talking about the UML thing in a second. And those tangents, I get about 4 or 5 of those tangents going all at the same time. I get stack overflow. So I mean, it's not really that bad, but I do ramble. I just like can't resist. I'm like, oh, there's another one. I gotta explain this. I've never talked to anybody about it before, so I don't understand. Like, I never got that like sense of like, and it would be nice to have the like unconscious normative impact of like having to like be around somebody that is like vastly superior to me in skill. And actually, I have so much to learn from like most people that I'm around. It's just like um, I was around more people like that. Like and then like when you don't talk to enough people who like work in your trade, then you don't know you don't know what you don't know, and then and then you think you're the shit, and you like, and nobody else understands why you would even think that, because they're like they like oh my god, they play with like Docker and Kubernetes and CoreOS like, and they're not like that's old news, and like okay, so PKG Cloud is another good library to look at. If you browse through the source, you're going to see library or logic for like abstracting across like multiple APIs. The best way to like internalize the specifics of the APIs for a cloud provider is to figure out like if they've got like a open API specification, and then there's lots of tools that you can use to just like generate plant UML or some kind of UML like description. Um, and then from there you generate like the graph viz diagram, and it just gives you like and when you do this on a Swagger JSON, you kind of have to like filter it before you generate the UML. So when you filter it, you're gonna want to take out a lot of the like high level like API route objects, because like basically like you have the API route objects, and then you at the lower level like they all reference like the API response like I guess in OpenAPI 3 the routes will reference the like components. I think they restructured that as components. Something else in OpenAPI 2, but anyway, you get pictures. You get to look at like you get to instantly evaluate like you can generate these things like in less than like 30 minutes, and then instantly like understand like how and why like the best like software architects in the world like chose to use like certain like patterns in their software. And of course, a lot of times like they change the design like in minor or major ways, like because they have problems with scale that you'll never have to deal with. So like there's things like that you kind of have to like take with a grain of salt, but it's just like almost like a cheat sheet for software design, and it allows you to evaluate a large amount of like information quickly. And as long as like the project that you're looking at has like a REST API that has a Swagger JSON, then you can get all of that like for free. Like if it helps you to like use that to like consume the like API definition like information, so you can like have your service use those services. That's helped me a lot. Finding like another great project for learning about cloud stuff is Hygiene, which is software from Capital One. So this is another project that has like cloud agnostic functionality, and it's like kind of like a mono repo with like several projects under it. And this is software that Capital One built to solve a lot of the problems they had with like DevOps and like managing information related to DevOps, and like making it easy to access like information about like what builds were live, what was like ready to go, like what tests had failed, like how often like test resources were being like used to run like integration tests for various projects. And for like large corporations, that is like if they're doing a lot of development in the cloud, a lot of continuous development with continuous integration, they are going to be that this would help. But you have to have like some like minimum of like projects to like run for it to like really like pay itself off. So it's really something that only like a large organization is going to need, but like anyone can like. I found this library like especially useful, and like quickly coming up to speed with like how these kinds of like I used this project to quickly come up to speed with how like people had approached like automating and distributing like tasks for DevOps, and distributing the information related to those tasks. Like so, Hygia like just basically lets you like manage it gives you a central place to like manage DevOps, and to manage it, but you manage it from like the perspective of like the like I don't know. It organizes all your information like in a very concise user interface, and it tells you like it gives you a very like efficient and fast like overview of of the state of your software projects. And for especially for large corporations that have uh, like that offer software like products on the front end that on the back end are composed of many micro services. Um, like those kinds of corporations will those kinds of like large scale businesses will run into lots of issues like related to like versioning or like maintaining like a repository of information related to like where and how many of like a certain version of a microservice has been deployed. And because when you break everything into microservices, like if they're completely separate software projects, uh, one, it can inflate the amount of code that you have to write because you have to like duplicate a little bit of business logic here and there. But then two, like if like now you have this like chart of like interdependencies. And so it's just like the dependencies that are pulled down from Node.js, and occasionally like Node.js runs into this like circular dependency issues that it has to resolve. Every package manager like basically has to like solve that problem or avoid it. And with microservices, if you have some of those like circular like references in your large scale network and service architecture, then you're like you're gonna have to proceed in changing out like services and deploying services in particular ways to make sure that like nothing breaks when you do it, or like and so if you don't know what versions of software have been deployed, like how do you know how do you, and it's just like the thing I was talking about earlier, like you have to look. You don't you don't know. You can't instantly know. Like so you have to ascertain, you have to look, you have to like direct your focus and like direct your work to um towards like collecting that information that you don't have. Whereas this project basically allows you to just like instantly know that stuff. But again, like there's so many like things you have to set up that like it would only be worth it. I don't even know how large your organization would need to be and how much software you would need to be putting out for it to be worth it. But it's really it's a fantastic like set of examples for like how people approach abstracting these like tasks and these and everything into like I guess what they call like collectors. But it's it's just like I mean it's a large scale like software product. I think there's like several services like in just the DevOps like server itself. So um, and in this project there's a lot of like good practices for like how to like in order for you to like work with the design of this and like add like configure your applications to be built and configured and like queried, like they need to be like designed as like 12-factor apps, and they need to be like modular and like capable of being deployed like immutably, and they need to be um, yeah, you got like so by looking at this, you can see what like what the guys at Capital One thought would be like one of the best ways to like tackle like wiring all those things together between like services and like manipulating services as though they're like objects, uh, like in a in a in a very large scale like program, because basically you want to be able to run your application like in very flexible ways. And if you don't I don't know if disaggregate is the word that I'm looking for, but if you don't like set up things in the right way, then you can't you don't have that like flexibility. And if it's uncertain whether or not like you'll need that flexibility, then you'd rather like if you approach things in the right way, like using the 12-factor methodology and like do things like ahead of time, then if like you're wearing a lot of hats, then like you can basically like avoid getting bogged down in certain problems. Anyway, so I think my my Facebook live stream is probably cut off by now, but all right, I'm gonna take a break. I'm gonna set up a Docker image that's got the things I need. I haven't messed with that in a while, so and I might stream later, I might not. But I want to get it to the point where I want to get this project to the point where I can just like hit the ground running and actually write code.